All right. And of course, I just had a large tow truck pull up outside my house for a van. So I do apologize for any loud noises that may occur here. But welcome to the first ARM radar listening session in what will be a 4-part series. This first one will be going over the state of the radars. So really, this is meant to be a conversation. We want to get a lot of the information out there to the user community. So we're going to be talking about the FY22 radar plan. Andrei will come in and talk about the radar status and expectations. Jennifer will be talking about the SACR measurement review, VAPS and data products, and then we'll close it out by talking about the radar strategy and have an open discussion there at the end. I know we have 2 hours allocated for this, but depending on how this goes, I don't expect that we'll use that whole time, and you can have some of your time back. So feel free as we're going through this, at least in the initial sections here. If you have questions, feel free to raise your hand, enter them in the chat. We'll be actively monitoring that as we go. So with that, just as a brief introduction, and before we really dive in, for those that maybe aren't as familiar with the ARM world and the ARM acronyms and definitions, if you go to the arm.gov website, scroll all the way down to the bottom in the footer, there is a glossary and acronyms list that you can click on. There's a lot of information in there. So if there are acronyms that we bring up that we don't define, and being in ARM a long time, I tend to do that a lot. So please, there are resources there at the main arm.gov website. So ARM has a complement of 32 zenith pointing and scanning radars. The table on the right shows a lot of those. There's also not included in this count are the radar wind profilers. But for our purposes here, we're talking about our zenith pointing and scanning radars. So we have a dedicated team of radar mentors, engineers, technicians, and the broader ARM infrastructure that are supporting these measurements. As you can see from our history here in the plot on the right, there was a large increase in the number of radars deployed back in the 2011 timeframe. And our staffing levels at the time, in the bar graph there, didn't quite line up with that big increase in the number of radars. So we've slowly kind of added to our radar team over time, with it somewhat being fairly stable over the past few years at around 10. And I know Andrei and his team are actually looking to add more to that as well. But because of this somewhat of a mismatch in the number of radars we have in the field and the effort that we have to put towards them, we have to establish priorities every fiscal year and cycle the radars through periods of maintenance and focus. And I'll talk about that more in a little bit as part of our yearly radar plans that we produce. But going back and highlighting our team here, our radar team, so there is a wide variety of people that are contributing to ARM's radars. Our mentorship team has been split into a dual lead mentorship, with Andrei leading the engineering team and Yao Chen leading the data mentor team. We also have the data quality office that's actively involved in the data side. We're engaging with other national labs, vendors, universities for different purposes and needs. And of course, our value-added products and tools teams, our cloud radars led by Scott G as the lead translator there, and precipitation radars and PyArt being led by our translator, Scott Collis. And of course, we have our constituency groups as well that we're working with. Clouds and Precipitation Measurements and Science Group, and then the cloud-related ASR working groups as well. So there is a lot of people in ARM that are involved with the radars here. So now, why are we here today? Well, one is to have a discussion, to be able to communicate, with our users, with the science users, on where everything is, what our plans are, how we're planning to address these radar systems going forward into the future. Part of this is from the 2020 Triennial Review. We were asked to develop a radar strategy to maximize the impact of the radars. And part of that was developing a roadmap to operations to better plan and prioritize resources. And in that roadmap, we need to define or redefine, I should say, our scientific goals and priorities for the fixed site radars. And I say fixed site because for our mobile facilities, those radars generally are justified, by the PI through their proposals. And it's really our fixed sites that we need to define this for. We want to look at different scenarios, understand the timelines to best address these scientific objectives and priorities, and pull that in to help us plan our operations better. So over the next few weeks, every 2 weeks in particular, we will be focusing on a different fixed site. And having a discussion, really looking for feedback from the science community to help us drive how to manage these systems better. So in 2 weeks on March 16th, we'll be talking about the Southern Great Plains site, which is home to 3 X-bands radars, our C-band radar and a Kaiser. The NSA site, the North Slope of Alaska, we'll talk about on March 30th. Which has our X-band precip radar and our 2nd generation KAW SACR, which is our cloud radar. And then of course our Kaiser, our vertically pointing Ka band. And then we'll close it out with Eastern North Atlantic, or ENA, on April 13th. And there we have our 2nd generation X-band precip radar, and then our KAW SACR, also 2nd generation, and then our vertically pointing Ka band. So as we go through, we really are looking for your feedback here, and I'll talk more about that roadmap later on in the radar strategy section. And again, if you have questions, if you have any thoughts or input, please put it in the chat, raise your hand. We're happy to interact here as we go. So with the FY22 radar plan here, now, we've been developing radar plans each fiscal year dating back, I think, to 2016. This is our way to set and communicate radar priorities because, as you saw, our effort, the amount of effort we have to put towards the radar did not increase as much as the number of radars we have to manage. So this is how we set these priorities, and we communicate that out to our users. These are available on the ARM web pages. They've always been available through the search tools, I believe, but we are trying to get better at making them more publicly visible and available. So if you go to any one of the any of the radar instrument pages, you can see in this reference box that's highlighted a link to the current FY plan. Now, in the past, we've generally gotten these plans out partway through the fiscal year. Going forward, we're going to be working hard to make sure these plans are out ahead of the fiscal year and visible for our user community to take a look at. We're also going to be engaging with our constituency groups like our CPMSG, the Clouds and Precipitation Measurements and Science Group, and others as well to get feedback on these plans. Now, for the FY22 plan, I will say we break this down into primary and secondary activities. As with most of our past plans, maintaining Kaiser operations and our mobile facility campaigns generally take a lot of the focus. We have Kaisers at each one of our fixed sites, and these are all operational right now. And Andrei will talk about the status of all of these systems later on after this. And mobile facilities, as I mentioned, these are normally one of the prime areas of focus. We have tracer operations going on right now. We have sail operations in Colorado, and Andrei and his team are preparing radars for EPCAPE and for AMF3 that's going down to the Southeast United States. And as you can see here, We do note that the CSAPR 2, which is currently deployed for Tracer, will eventually be going to support the AMF 3 campaign for Arm Southeast. And this is going to leave a gap in our mobile facility capabilities. So we are actively looking at options to replace that capability for AMFs 1 and 2 and for other field campaigns that may arise that need them. So that could be anything from refurbishing an existing system that we have to procuring new. Again, we're looking at our options in this route. This roadmap to operations that I mentioned earlier, and I'll talk more about later, we're actively engaging on that and building it out. And like I said, I'll talk more later on that. And looking forward to the future, Andrei and his team are actively working on developing a maintenance plan for these EIK tubes for our Kaiser and Sacker. It's definitely a lot cheaper to get these tubes refurbished versus buying new. So we're looking at how we can manage this and develop a general maintenance plan going forward. Now, the secondary activities that we have generally are ones that will be given attention as time permits, and I'm sure Andrei will talk more about these in a little bit. But essentially NSA, ENA, those radars are part of the secondary activities, and Andrei and his team have done a lot of preparations and work to set up repair trips in the future for this. So they've packaged a lot of hardware, a lot of tools, and sent it over to ENA. They're planning for a trip to NSA. Again, this is normally when time permits and as travel permits as well. Additionally, his team's been working on the SGP XSAP or magnetrons replacements with those on site, with our radar technicians on site. And that'll be something that we look at going forward as well here. But again, these are the secondary activities and do fall behind our primary activities that we normally focus on. And for the radars that aren't listed here, like our C-band at SGP, that kind of leaves very little time for that. And that's what part of the strategy I'll talk about later is that we want to look at all of our options going forward here with these radar systems. So with that, I will actually open it up for some questions, or we can dive into Andrei's update here on the radar status and expectations.
Okay, good morning and good afternoon. I would prefer to have a little bit later after summer this presentation, because past 2 years and travel restriction just didn't showing the radars in the best situation which we have with them. Please, the next slide, please. So our focus was the campaigns, the two ongoing campaigns, and they were our first priority. So the Tracer campaign and the SAIL campaign. In the Tracer campaign, we have 4 radars: KX-Sacker, the Kaiser, and the CSAPR. I think that was in the past 10 years my worst campaign. This one, the Tracer. We started with the Sacker with all the problems in the past 3-4 months. Almost half of the radar we replaced it with all travel restrictions and everything. In mid-February, we changed the slip rings, some cables, power cables inside the radar pedestal. They were related to some design problems. We were happy because the new cables just worked properly and our design was much better than the previous. And the Thursday or fourth day, the Sacker pedestal just failed with the elevation problem, so we cannot scan in elevation now. The radar is zenith pointing now. I'm not sure that we are collecting data. We are operating the radar to check the system stability. Besides the elevation scanning problem, the X radar has a offset, 6-7 dB offset between the two channels, so we need to fix this also. Kaiser, it's working properly. We have little problems with the Kaiser. The Kaisers are our best instruments, so it's no scanning, it's no water cooling with this instrument, so they are our base instruments, so I don't want to talk more about the Kaisers. The only problem with the Kaisers, the transmitter, the TVT amplifier, the vendor will accept 2 more units for repair, but they told me that still they have problems with these units to find the parts for these units, so they will look for a solution. Maybe we can replace the power supplies, the power supply modulator for the traveling wave tubes. So we would like to keep the very stable and clean signal producing TVT amplifiers on the Kaisers. We have a second solution with the EI case from the solution which processing used on the second generation of the radars, but we have problems with the signal purity, and my favorite is the TVT, the traveling wave tube, and I would prefer to use in continuous activities for the Kaisers. C-Support 2 had a big upgrade, software upgrade, so the C-Support is proposed to do remote cell tracking scans, external cell tracking software will be able to control the radar automatically, remotely, so without operators' intervention. We are working together with GAMIC and Brookhaven National Lab, and working on the cell tracking software. We did some tests. It's still not working properly. The results are promising. Probably in the upcoming days with GAMIC, we will fix it. The part of the remote control of the C-Support 2. About the signal quality, we have some issues with the stability of the system. The noise floor, it's just randomly rising. In the past days, after a software upgrade, the situation looks much better, but I have this feeling that it's still there. So maybe we have just multiple issues with this noise floor fluctuation. This can be just solved by some site measurements. So it's an upcoming visit in mid-March, maybe March 13 will be the travel down date to Houston. It's still we need domestic travel approval, and we will try to address all the problems at the tracer site. So we'll fix the sucker elevation scanning, the X bias, X radar bias, and we'll try to manage that floor as noise floor fluctuation with a C-Support. So this is our first priority. I hope that mid-March will be possible to visit the site and we can fix all these issues. In sale, we have the Kaiser. With the Kaiser, we had at the beginning some problems, but it's very remote location, it's no access to the site, and as usual, the Kaiser behaved well, so we had a transmitter problem that was replaced, and in few days we could manage to turn back the data acquisition. So these are the two campaigns, and all our effort is going to these campaigns, and in between these trips and time spent with the campaign radars, we are working on the other sides. So thank you. I will present the situation at the permanent site, so north slope of Alaska, the NSA site, where we have a KW seeker to the second generation of the seekers. This radar had multiple problems on the W side, so we asked the local operators to pack up the radar instruments, the radar units, and send to PNNL. And we set up on the bench, and team did a great work on fixing, testing, fixing, and calibrating these units. The problem is because of COVID, we have huge problems with the parts. So between the two second generation seeker, we have to share some components which will be available later this year. And this maybe delayed our work. So KW seeker, it's almost finished at PNNL. All the measurements were performed. We know which are the parts we need to replace, and hopefully early this spring, I'm talking about the Arctic spring, so probably that will be May, we can make a trip and we can fix the radar at NSA. The Kaiser is working properly. The X-Zapper has a transmitter problem. We replaced it, but only the site operators replace the unit. It needs some tuning, some special attention. The X-Zapper, I didn't insist, were not plans for the X-Zapper in the Arctic, so we'll have the radar to rest, and we'll put back the X-Zapper during the first visit. We have the transmitter there. Maybe I will take another replacement just in case if we will need, and we'll try to solve all the problems in one trip. ENA, Eastern North Atlantic, the situation with the KW seeker was the same. Major problems with the W part. Both radar were here at PNNL. Team did a parallel work on the radars. We considered that because it's winter in the Arctic, we'll manage the ENA radar first. So that was fixed, shipped, and yesterday just arrived to the island, Graciosa Island. The first image sent were about a cracked pelican case. It's the first one I saw in my 25 years field work, a cracked pelican case. It looks that the unit was not damaged. The site has 2 more K modulators. This is an 80-pound modulator. It was a huge pelican case. I think that it's rated for few thousand pounds to resist the pelican case. I have no idea how they were able to crack it. Maybe they put under the sea containers, or I have no idea how it could happen. But this is the way how we are dealing with the field work, so we don't know how other parts were shaped and how they was handled during this transportation, and what surprises we will have when we will get to the site. Kaiser 2 is working properly at the island, and X-Zapper, it's functional. It needs the calibration. A couple of hardware issues we are prepared for that hardware issues. So probably during the visit, we are preparing to service all the 4 radars. And we have a travel request for already submitted. My plan was to go there early April. However, it's a gap now in the COVID situation that probably would not interfere with our travel. However, the new Eastern European war maybe will put some restriction on the international travel. We don't know yet, so it's still in our focus. So we would like to address and go there in April and fix these radars. If it's not possible, we will move forward with the NSA radars and we'll make that trip. SGP, in SGP only operational radar is a Kaiser. Some small issues are with the Kaiser, but we are still collecting data with the Kaiser, and we have good site technicians there, so the Kaiser will be not a problem to maintain it operational. The X-Zapper network, so we have 3 X-band radars, I would say, in conservation mode. So these radars are powered up, they are moving, they are scanning very slow to keep all the parts functional, powered, and we are not collecting data. The transmitters are off or in service, but this network with little effort can be made operational. 2 of the transmitters are working. The third, this is ready for service. We have the magnetron for it, so it's just a matter of days to have the third X-band transmitter operational, and this network just need a calibration. That means 2 days field work for each radar. So that is with the X-Zappers. The KW Sacker this spring was retired. It's still in SGP. I would like to use this radar for engineering purposes, so we will move it to PNNL. Unfortunately, it's a huge delay in the radar components, parts, shortage, so probably we will have to use this radar as a source for spare and replacement components. If the situation will improve, maybe we can make this radar again operational. We'll see. So at this moment, probably we will need 4 parts. I will install the last elevation motor in Houston during the upcoming visit. If we need, I do not have any elevation motor, parallel elevation motor, only the one which is the SGP Sacker. The C-Zapper, the old ARC radar, it's just sitting in SGP. The receiver and everything would need an upgrade. It has a very good antenna. It's 1 beam degreed C-band antenna, similar with the C-Zapper 2. A robust positioner, easy to service positioner, 7-foot tower. The transmitter is a very old design magnetron transmitter, so that radar with little effort can be make it operational. With the X-Zapper network, we had a nice campaign, a short campaign. So we use 2 radars in dual Doppler modes, and the third radar was used for cell sampling. Anytime I can imagine a application with 4 radars, the X-band, with a renewed or refurbished C-band radar. I think that the SGP still have capabilities with this radar network, and maybe will present in the future more interest for the scientific community. That is with SGP side. So here at PNNL, we are preparing 2 of the upcoming campaign for the AppCape. Team just started the test with the KW Secker. This is the old generation, was in Norway at Campbell. Last time this radar, it had problems with the W band also. He's mastering now the W band measurements, so it looks pretty good, this radar. He's doing some slow scanning. I didn't have time to ask him what he's doing, what he's collecting, what is happening with the data. He will tell us later, probably during these sessions, and you will have an upgrade on the KW Secker for the AppCape. The radar will be ready in time. Hopefully, will not have big components failures. I don't know what is the best we did for the tracer. We ran for 6 months the radar here at PNNL with little problems, and when we move it to Houston, it's just started to fail everything. So I don't know what is better now. Just operate couple of days every month the Secker here at PNNL and see if it is still operational. Just do what we are doing with the sappers in SGP. Just keep it moving very, very slow with 1-2 degrees per second movement to have all the parts operational. We'll see. The deployment will be at the end of the year. I don't want to fully operate on this interval here at PNNL. That will affect the fluid rotary joints and everything. So we'll try to make some breaks for this radar. When it's cloudy, probably we will operate to have some data for the data team to evaluate the radar performance, but we'll have to keep it off for saving the components and for the campaign. For the southeastern United States deployment, we are preparing the KX Secker. It's not a final decision. This is the Argentina radar which came back with multiple problems. Wagner was working on it. We redesigned the cooling system. He did a very nice job on the cooling system. It's still not finished. We had to remove some parts from the pedestal to take it to tracer, just ready for installation if we are making the visit. But end of March we will move in the radar yard and we'll start to populate up this radar and start the test with radar. And also we have here, without any plans, the former radar from Mosaic, the KAX Secker, on the sea container platform, so which was used for the Mosaic, for the Polar Star, and it has a big pedestal, a big orbit pedestal, a tall, huge pedestal which easily handles the 2 radars. We didn't have big problems with that orbit pedestal. That is our best pedestal from orbit, I think. So if I miss something, please ask me. This is the current situation. I hope that by the end of the summer we can improve the status of the radars at the fixed sites. So.
Thank you, Andrei. We'll actually skip that. Are there any questions here on any of the status updates that Andrei provided? Again, feel free to raise your hand or enter it in the chat. Otherwise, we can hand it off to Jennifer here to talk about the SACR measurement review and the outcomes of that. Let me stop sharing for you.
Do I need to swap my screen?
Yes.
Okay.
Yeah, that looks good.
Does that look good? Great. Okay, I'm gonna be starting off talking about the SACR capability review. And as Andrei mentioned, we recently retired the SACR at the SGP site. And so that was a result of this review that we did, and I'll go through all of that. So ARM routinely reviews its capabilities, and the idea is to support, we want to support the most impactful instruments and measurements and support the ARM mission. And to do that, we are constantly updating our capabilities and bringing on new capabilities. But to do that, each time we bring a new capability on board, we have to maintain those systems which requires mentor effort, hardware costs, maintenance costs. We have a number of people who look at data quality assessment, and we need to provide data products and develop ingest and value-added products. And it all takes computational resources to transport data to the archive and process the data. So there's a lot of costs that go into each capability that ARM deploys. So in order to add new capabilities, we need to evaluate our existing capabilities and sometimes retire those capabilities. And as a result of triennial review recommendations, we were asked to develop and implement a process for reviewing these capabilities more formally and do these reviews on an annual basis. So we'll be in the future each year reviewing instruments and data products to start out with. So the first formal review we did using this process was to look at our scanning cloud radar systems. And I just want to go over a little bit about the review process that we've developed. We have first identify the evaluation criteria that we use to evaluate each activity capability, and this can change from capability to capability. There's quantitative measures that we can use to evaluate these capabilities, such as data usage, uptime, scientific impact, and costs. And there's also more qualitative measures such as uniqueness or the future impact. And so we take some of these into consideration. For the SACR review, we identified 4 criteria that we included in the review. And that was scientific impact based on publications and citations information, data usage, which included unique users and data downloads, costs, such as mentor costs, spares and repairs and maintenance costs, and also instrument stability and uptime. That includes data availability and maintenance that goes into that. And so we had a team of 4 infrastructure members who were part of a team to perform this review. And as a group, we identified we weighted the evaluation criteria because each of these criteria don't necessarily have equal weight. And so for the SACR review, I'm listing them from highest to lowest. We felt scientific impact had the highest weight in the scoring system that we used. Data usage and costs actually had equal weight based on our weighting factors, and instrument stability had the lowest weighting factor. Once we determined this, we took all of the SACR systems and went through each of these criteria and developed a weighted score for each of our instruments. And so I'll summarize some of these findings and our recommendations. So I just want to give you an example of some of the results that we had. It's easy to look at publications from the publications data, the ARM publications database. And so this chart just gives you an idea of the number of publications we have for each of these radar systems, as well as some of the subject areas that we've had some impactful science come out of these areas. On the right is the scorecard that after weighting or evaluating each of these instruments, we have a scoring system, and this is kind of the results of the scores. So just one thing to note is that a high cost score is actually means that the cost was low and reasonable, whereas a low cost score meant it was expensive. So a little counterintuitive. So for looking at the AMFs, as Andrei talked about, we have the radar team focuses a lot each year on the AMF deployments. And starting with the cacti campaign, this has really resulted in better uptime of those systems. And that really comes out in the scores and the number of publications that we're seeing coming out of some of the radar systems that have been deployed with our AMFs. At the fixed observatories, we've had less of a mentor focus on the SACR systems, and this has resulted in some higher costs, as well as a less impact in terms of scientific impact. We've also noticed that our SACR2 instruments had higher impact and scored higher, and we also found that the site scientists' focus on ENA and ELICTOC did boost that impact in some ways. So to go over the recommendations that we had, as I mentioned, we recommended to discontinue SACR operations at the SGP observatory. That system has had extensive maintenance issues, and it did not realize the potential was not realized in that system. The target was shallow cumulus clouds, and it did not have the sensitivity to detect the target cloud systems and support the LASSO high resolution modeling efforts. We also recommended to continue to support the SACR deployments with the AMF campaigns when the science objectives are well justified in the proposals and they're focused around clouds and precipitation. Those are really the campaigns that have had the highest impact in terms of publications and high impact science. For example, we've seen from our high latitude campaigns, such as BAKE and ELICTOC Point, the KAX systems have provided, have provided a lot of good information from the convective regimes as well with the cacti campaign. So we're seeing the impact there. And so we recommend continuing to support those operations. We also recommended to consider a redeployment or reconfiguration of the ENA SACR2, which is a KAW band system, due to the high potential value of that system. And for this system, very little data is available at this time. As Andrei mentioned, it has been difficult to maintain that system due to the remote location, the export issues, and getting the time it takes to get parts to the site and things like that. But we recognize the value of this, this system. And so we are seeking community input to identify avenues for obtaining higher impact science from these systems, whether it means we reconfigure it in a way that makes it easier to maintain or redeploy it to a new location. And that is something that we'll talk about in one of our future listening sessions focused around ENA. We also recommended to continue to support the SACR2 system at the NSA. That system was originally deployed at the Aliktok Point site and has moved to NSA when the original SACR system was retired there, which had reached its end of life. We also, the last thing we recommended, we thought a bit about how to improve the impact of the SACR systems at our fixed sites. And we recommend deploying these in more intensive observing mode with focused scientific objectives. And so the way this would work is we would have more focused short-term high quality data, which has been more valuable than the lower quality long-term measurements. And by using a proposal process, users could request certain scan strategies that complement their scientific objectives. And so that's another avenue that we think that we can improve the impact of those systems. And we have some examples of users have requested certain scan strategies, such as at Southern Great Plains sites for our XAPR systems. And so this would be a similar paradigm. And so I will take any questions that you might have.
Definitely a quiet group today, so feel free to.
Jennifer, I have a question. What is short term? What kind of scale is that?
I think that's so up to debate. I'm sure in regards to the last bullet that I talked about.
High quality, yeah.
Short term, high quality. Well, like an AMF deployment. We found that when we focus our efforts around a mobile facility deployment and that the scientific objectives of that deployment is fairly focused, that we get a really good result out of that. And so that's kind of, I think, that year time frame is what I was pointing to. And thank you, Michelle. I see you. There's a more extensive article about this on the news page if you want more information, or you can reach out to me. Any other questions?
No?
Okay. I will then move on to the radar science products. And do I need to swap again?
Nope, you're good.
Oh, okay. Oh, worked that time. Okay. So this next presentation is going to focus around the data products that we produce that come out of the radar systems that ARM deploys. And there's a whole team of people that work on science products, including the radar data mentors, Ya-Chen Feng and Alyssa Matthews and Karen Johnson. And they really focus on the quality assessment, the corrections and the calibrations of these data. Then we have our science translators and several of we have 5 translators, but Scott Giograndi, Scott Collis, and Damao Zhang really focus on the higher order data products that come out using the corrected data that the radar produces. So we'll talk a little bit about those. I wanted to mention the data levels because we'll be throwing around these terms throughout the talk. And if you're not familiar with ARM's data levels, this will provide a little guide for you. The raw data is converted to what we call ingest A-level data. And this takes the raw data and puts that into geophysical units and standardized NetCDF files that adhere to ARMS standards that we've developed over the years. B-level data is taking that raw data, A-level data, and providing additional quality control to those measurements and corrections and calibrations as they're known. And so Alyssa Matthews will be talking about this section, the B-level data on the next couple of slides. And also the C-level data is where we apply typically multi-sensor retrievals. We call these our value-added products. And they are typically applied using published algorithms. And so this is would be like our microphysical retrievals or cloud phase retrievals or things like that. And we'll talk some more about those also in the talk. For processing, we have, to give you an idea, our initial processing, often, particularly for mobile facility campaigns, where we develop the calibrations and corrections at the end of the campaign. Initial processing to provide data during the campaign is at this V0 level, and then we run our VAPS at the C0 level. Once the corrections and calibrations are applied, the final processing is at this B1 level or C1 level, and that's really the recommended, what we recommend for doing science. For if you want to apply your own retrievals, use this B-level data, or if you want to use our derived products, the C1 level data. And so Alyssa, you want to go over the last several years, the radar team has developed a new system for getting the calibrated data sets, and Alyssa's going to talk about that.
Yeah, thanks, Jennifer. Can you hear me okay?
Yes.
Yeah, great. So there's kind of two main roles for the radar data team. We do our daily checks and the B1 calibrated data sets. So the daily checks help us kind of make sure the radars aren't getting too crazy in the data. So we monitor the ingest to ensure the data is flowing, visually check our online plots, and then investigate any suspect data we see in those online plots and communicate those with the engineering team, create QPRs as needed, et cetera. And then we also are working to provide higher quality corrected data for scientific research with our B1 calibrated data sets. The first one of these was done for the cacti campaign, and it's had a lot of really good use out of that data. And we follow a similar basic flow each time that was first created by Joseph Harden. We try to follow it for the basics, but every site has new challenges, or there's different instruments that we can compare with. So we're constantly working also to implement and develop new data quality control methods. And always, if you have any questions about any radar data, B1 or raw, just email us at radar@arm.gov listed here, and we're happy to answer your questions. Next slide. So this is just a visual look at our kind of plan we do for the B1 calibrated data sets. And we do reflectivity corrections, which can include more engineering corrections like corner reflectors, but also the RCA technique developed by Joseph Harden and Alexis Hunsinger. Self-consistency, cross calibrations with ARM radars, and also external ones. For instance, for Tracer, we're going to have ability to cross compare with NextRad. And then comparing also with astrometers, RWPs, et cetera. We do ZDR corrections using vertically pointing when available, or as close to vertical as we can get with the horizon to horizon RHI data. We calculate derived fields for radars that would require them, like KDP calculations. And we also provide masks for the radar. Some radars provide masks themselves, but we also provide ground clutter and blockage masks and meteorological echo masks as well. So thank you.
Thanks, Alyssa. Okay, so now moving into some of our value-added products. Let's see, Karen Johnson, do you want to talk a little bit about the Sacker products?
Sure. Hopefully you hear me.
Yes.
Great. So for the scanning cloud radars that ARM operates at various sites, the value-added products the current ongoing, currently being produced value-added products are called, value-added product is called Sacker Grid. And that one operates right now on RHI and PPI scans, which are the primary scans we're operating these days. It provides radar moments, essentially converts them from the polar grid that the radar stores the measurements in into an easier to use Cartesian grid. It also applies significant detection masks and includes corrections for gaseous attenuation. Now, these products are available currently for cacti and for combo at what we call the C0 level, which is uncalibrated. They're also available at cacti for with calibrated radar data. And this sort of puts everything in an XY grid, much easier to use. We are currently looking at tracer, K-Sacker and X-Sacker measurements to at least get the algorithm up and running. Like Andrei discussed earlier, there's been some availability issues kind of off and on with the Sacker so far, but we're hoping to get everything running well later in the campaign, and we'll be producing these products if that happens. And we've also got these products are implemented such that they can be extended for future expansion. For example, echoplastification, drizzle, that kind of thing. But right now it's just a basic product that puts the moments on a Cartesian grid. We also have some episodic products with the acronym Sacker ADV, or advanced products. These have been developed for episodic periods in the past and are available on request if future campaigns provide the appropriate scanning mechanisms to produce them. But they include velocity azimuth displays, just a second, which can, based on HSRHI scans, can give us horizontal wind speed directions. And also the 3D 3C, that is actually has turned into the Sacker Grid product essentially now, converting to Cartesian cloud cover. But we do have older historical runs of this 3D 3C version of Sacker Grid available. And then finally the QVP, Sacker ADV QVP, which is what we call quasi-vertical profiles. These kind of are a condensed summary of complex 3D polarimetric observations in effectively a vertical coordinate. They could be useful in determining particle habits and such. And we have those available at the LICTOC for a confined period of time. All right, I guess that's it for this one.
Yeah, we'll come back to the RC.
Okay.
We'll continue on talking about our scanning precipitation radar value-added products, and the primary product that we have for that one is our CMAC2, which is our corrected moments in antenna coordinates. And the development of these products are led by Scott Collis at Argonne National Lab with Bobby Jackson and Zach Sherman working on the algorithms and producing some of these data products. The CMAC2 provides rainfall retrievals and gate ID retrievals, as well as the corrected moments. And this has been applied to X-Actor data at the Southern Great Plains for select time periods between 2018 and 2019. We also have CMAC2 applied to CSAPR2 data at cacti. And that has been derived with the calibrated B1 level data. And also we have, with the cacti data set, we have some metadata tags that identify cloud regimes for those cases. And those were tags that were developed by the PI Adam Varble. And you can find those in the data discovery tool. We also have some short time periods of Cartesian grid moments mapped to a Cartesian grid MMCG products at SGP, some short time periods at SGP and TWP. And these corrections apply aliasing, second trip, and folding corrections are applied to those data as well. as some quantitative precipitation estimates at SUP and TWP as well. Scott Colas, are you on? Do you have any further?
I
add anything in?
am. I just want to, first of all, also thank you, Jennifer, say that we've also now had Max Grover and Joe O'Brien join the group. We're really excited about that. And you covered it really well, Jennifer. One thing I want to hammer home is CMAQ2 as a framework. We will run algorithms, published algorithms based on the needs of the deployment and the site. And all the code is open source and available in the Python ARM Radar Toolkit. Thank you.
Perfect. Thank you, Scott. Okay, I wanted to go over some new radar product development that's happening. And we have a new cloud phase algorithm that's being put together by Damao Zhang, where he's applying the phase classification algorithm in the SHOOP 2007 paper, publication. And this is being applied at our high latitude sites at the moment. He started with the North Slope of Alaska site, and by combining the HSRL and Kaiser R-SCOL data at that site. And this will provide a rain, drizzle, phase classification, mixed ice or liquid, and also snow classifications. And implementing at NSA, and then we'll also provide next some results from COMBL. And this should be available later this year, so look for that. We're also, Scott Giograndi's group has also worked on an update to our microphysical retrievals we're calling Microbase Plus. This provides baseline liquid water content and ice water content retrievals, as well as effective radius derived using Kaiser and microwave radiometer measurements. Additionally, this data set has uncertainty quantification, including additional multi-sensor evaluations such as closure studies and comparisons using radiative transfer calculations. And we are discussing combining the cloud phase algorithms and results with the Microbase Plus in the future. And that'll be some future work that we work on down the road. And I guess we can't talk about radar products without talking about R-SCOL. R-SCOL is the primary VAP that comes out of the Kaiser type radars. And so I'm gonna let Karen Johnson talk about that. She has plans to upgrade R-SCOL. So take it away, Karen.
Yeah, well, first, for anyone that's not familiar with R-SCOL, I just wanted to briefly tell you what that is. It's a product that combines, as Jennifer said, the Kaiser, the vertically pointing Kaiser radar, with LiDAR and other instruments that all provide bits and pieces to help give us the most complete picture of clouds, essentially, over each site, directly in the pencil beam over the site. The current R-SCOL product is working and producing good results, but for example, it corrects for various radar issues like velocity aliasing and gaseous attenuation, provides mass for significant detections and for insects, provides best estimate radar moments, essentially, and provides cloud boundaries, base, cloud base, and cloud top for up to 10 layers. And good news, if anyone doesn't know, we do have near real-time availability now for R-SCOL up to about a month behind the data collection, and this includes the AMFs. Right now we have 3 months and almost 4 months available at both SAIL and Tracer. So the data is in the archive now, and feel free to grab it. However, R-SCOL is not without its issues. Insect removal may remain challenging. There is, for example, the whackers are another radar, vertically pointing radar that ARM has, and it will probably still occasionally be deployed. We need to unify the code bases of the Kaiser and the whacker. We also don't have a lot of flexibility for adding new input sources. The code is not open source at all, and it's in a proprietary language called IDL, which we're moving away from in the program. And it doesn't incorporate some of the newer Doppler spectra-based techniques for determining insects and discriminating insects from clouds and providing higher order radar moments. So this is where this next generation ARSCO concept comes in. It's in the design phases right now. It will incorporate new and improved input sources, such as the machine language based LiDAR cloud masks. And as I mentioned, the Doppler spectra-based clutter detection is much, much better and can remove any manual oversight, essentially, of the product, which we still have to kind of review the heights of insect layers from month to month at various of our insect-prone sites. We'll also have RWP-informed cloud top heights. In other words, the RWP can see all the way through the clouds to the top of the cloud tops, whereas, for example, at SGP, sometimes the radar cannot see all the way through to the cloud top because of attenuation by the liquid water in the cloud. We'll also have more site-specific inputs more readily, like, for example, COGS at Southern Great Plains sites. We'll be hoping to incorporate that into the stereo cameras. That's what COGS is, the stereo cameras we have available at the SGP. As I mentioned, we'll unify the ARSCO, the KASER and WACKER cloud code bases to just have a single vertically pointing cloud radar product in the new ARSCO. It'll be a more modular design and have additional site flexibility built in. We'll also be promoting community contributions to ARSCO development by coding in Python, a more modern language, an open source language, and open sourcing some key ARSCO functionality, making it available to the community to look at and improve as they wish. And we also hope to coordinate visualizations with the upcoming ARM data workbench. So lots of great plans, and we're working on the designs right now. That's it.
Great, thanks, Karen. Okay, and this last slide is kind of the kitchen sink slide to give you an idea of some of the other resources that we have for using and discovering radar data, as well as all ARM data sets. As Scott mentioned, we have the open source resources available. PyArt, developed out of Scott Cullis's group, is a great resource for utilities for processing radar data, input for reading and writing data, for visualizing the different, primarily the scanning radar products, and applying corrections. More recently, the Atmospheric Data Community Toolkit has been developed, and this is much more broader. It has utilities for working with atmospheric time series data, plotting, as well as tools for discovery, input, output, quality control, corrections, retrievals, and visualizations of all different kinds of ARM data. So I encourage you to check out those resources. The last open source resource I wanted to mention is the ARM Data Integrator, which is a tool for integrating and transforming multiple diverse data streams. So you can read in multiple different data streams like LiDAR data, radar data, microwave data, and put those on the common grid. And this particular tool applies the ARM standards to those. And this is, the ARM Data Integrator is used by our software developers within ARM. So this has been a well-tested tool. On the left, I wanted to mention a few new activities we have going on to help users find our data epochs, which are well-characterized quality controlled data sets. We talked about that today with the radar data sets. The B-level data would fall into this category, as well as the value-added products. We have also started to implement metadata tags, which you will find in the data discovery tool. And this is where we're starting to identify scientifically interesting time periods that are identified by users, as well as ARM staff. Together, we expect these features will help users find data more easily to discover, because we have a vast amount of data in the ARM archive. And so some examples we have already implemented from Cacti, the cloud regimes I mentioned earlier. Scott Cullis, his group has been working on tags for XEPR data at SGP and NSA, and those should be implemented soon. We have put a ticket in for identifying the cold air outbreaks from COMBL. We have those from the COMBL PI recently wrote a VAPS article, so we have those information from him. We've talked about also doing meteorological regimes at ENA and also identifying some aerosol conditions, clean or smoky conditions during our campaign LASIK. So these are just some of the examples, but we encourage scientists to, as they work with our data, we can talk about adding additional ones. So that is it. So I'll open it up for questions. Any of these topics?
Thanks, Jennifer. Any questions? Okay, well, feel free if anything comes up, just put it in the chat. I'm not seeing any hand raises or anything else, so let's move on. So thank you for sticking with us. I know we're over the hour of a normal meeting, and this has been a lot of information, but this really will be a nice way for us to kind of kickstart these listening sessions. There's going to be there is a lot of information here that we will be probably pointing back to in the subsequent listening sessions as well. So again, thank you for being here through this longer meeting. The last topic for today is the ARM radar strategy. So as I noted earlier, an outcome of the 2020 triennial review was, a request for, well, one, an updated radar plan. So we did that, and we're going to be doing that in a more timely manner going forward. And on ARM radar strategy and how we're going to address all radar operations. And this strategy was really broken down into 3 topical areas. So radar operations and management, radar support team, and community feedback. Now, one of the things that I mentioned earlier that is really one of the core parts of this plan is this roadmap to operations. So in order to effectively manage radar operations and provide that high quality data to our ARM users, the first step is assessing where we're at and defining where we need to go. So we're going to be looking at a few different areas. So of course, why we're all here with the science community as well, we want to set these scientific priorities and objectives and the timelines for each of these systems or groups of systems. We're actively working on defining the tasks, the effort, the personnel required to get each radar back to an operational state. And the personnel, I'm not just referring to, is it Andrei, is it Tim, is it Ya Chen? We're referring to, is it the engineering mentor team or the data mentor team or the DQ office or an external partner. We really want to use this roadmap to define the who can do these tasks so that it's not all on the mentor team all the time. We want to try and distribute that workload. We're refining our requirements for the continued operations. So again, once we get it to operations, what do we need to do to keep it operational, along with the effort required, and again, who can perform those tasks? Also looking at external partners here as well. Somewhat going hand in hand with the scientific scope, as we go through these listening sessions, we'll also want to look at what data products are available, and you saw a nice overview today. But with any new scientific priorities or objectives that are brought up in these discussions, we want to look at the data products and make sure we have what we need to maximize the scientific impact. At a minimum, going forward, if ARM indicates a radar is operational, we want the assumption to be that calibrated B1 level data will be produced. So another area here, the modes of operation. So as we kind of all have seen, our general operating mode of 24/7, 365 days a year has not lent itself well to our scanning systems. We would need a fairly significant amount of effort to invest in our operations to ensure this. I think previous estimates that were done years ago put this at 22 FTE. So 22 people to keep all these radar systems up and running. Now, we want to explore other methods of operations with the goal of maximizing meteorologically relevant data sets while reducing the operational requirements of the radar. So some potential modes, and Jennifer touched on this already, defining intensive operating periods at fixed and mobile observatories where ARM only operates or deploys radar assets for limited time periods. Somewhat adding to that though is, normally we have PIs, propose field campaigns, but there's another thought too that ARM could define an IOP period ahead of time, say that, for SGP, we're going to focus on the XAPR network in 2024. This is just an example, but if we could define an IOP ahead of time, we can get to the community to try and start to form around that idea as well, with other resources, other plans for field campaigns. Again, these are all potential modes of operation that we are looking at and considering. And if you have other ideas, please put them up in the chat or reach out here. Also, as Jennifer noted in her measurement strategy review, we are looking at reducing. We have reduced the number of radars deployed in the field with the retirement of the SGP SACR. But we also want to see how we can create more easily deployable assets to support field campaigns and IOPs. Just because we're removing the SACR from SGP, and as Jennifer noted, doesn't mean that we couldn't deploy it back there at a fixed site like SGP in the future with one of our mobile SACRs. Limiting the locations and or complexities of deployments for scanning radars, especially for our mobile campaigns. We have to really look at our risks of these systems and their operations. If we're somewhere very remote with very limited communications, does it make sense to deploy these radar systems when there's going to be very little chance of troubleshooting it remotely? Again, that we just need to weigh the cost benefit and the risks involved with these a little bit more carefully in the future. And one of the more interesting things here too is looking at smart systems to optimize data collection of scientific interest, looking at systems that utilize external data sets, edge computing, that sort of thing. These are all areas we want to consider as potential modes of operation. And of course, like I said, we're open to hear more as well. Some other areas, timely access to data products. So, calibrated data products, they've generally been made available after the campaign. And I think as we go through this, we want to look at where it makes sense, where we can improve the timeliness that all these products are made available. Not just the B1 level data, but the VAPS as well. So if there's ways we can streamline this effort, we're going to look into it and try and implement it with the understanding that we're not going to impact the quality of the calibration. So we're not going to do near real-time B1 level calibrated data when it takes 3 to 6 months to have enough data to do viable calibrations. So and was kind of noted earlier, producing uncalibrated VAPS. So running the VAPS on the uncalibrated data to produce that C0 level where it's reasonable. And then when we have that B level, the calibrated data set, process that data and have that C level available. Just ways we can speed up the data getting out to our users, from how we've done it in the past. Documentation development, I don't have to spend a whole lot of time on this. Essentially, we just want to make sure we document our processes. If Andrei and his team win the lottery next week and they're off on an island the week after that, we want to make sure no one's starting from scratch if they come in to take over for them. So, and this is not just on hardware, but on all of our processes, really. So, as Jennifer noted, with the radar measurement review, we're performing these measurement reviews on a regular basis, and we're going to continue to look at ARM's radar systems and capabilities, as well as our tools and processes that we use to support the radar team. So not just the measurements, but also looking internally, doing these self-assessments as well of how we can do things better. Now, switching over to the radar support team, as I noted earlier, we do have a dual lead mentorship, which is somewhat rare in the ARM program. So Andrei is leading the engineering side, Ya Chen is leading the data side. The engineering side, as known, is primarily responsible for the radar hardware and ensuring that the systems are prepared, maintained, calibrated, and operational. While the data side, as Alyssa was saying, they're responsible for overseeing the processing of the radar data to a well-characterized state, including the data analysis, the problem detection. They're working with the engineering team closely on calibrations and these problems that come up. So it is a dual lead mentorship, but really they're working closely together. And I do believe that, as I note here at TBD, Andrei is looking to add to his team as well, and that there are postings available. If you would mind circulating them around, that would be great to get more applicants there. Now, it's not just this mentor team. As I showed earlier, there's a broader group that is contributing. So, and we kind of want to continue to leverage and better coordinate the knowledge, expertise, and resources that these different groups, these different people bring to the radar landscape. Again, trying to shift the effort from solely on the mentor team and kind of spread that out across the infrastructure. So looking at our translators, our DQ office, our developers, looking at our site operations personnel, not just for the radars, but for other instruments as well, at potentially developing career tracks so that they can gain more knowledge and responsibilities with the radar tasks over time. So having the mentors define different tasks, different requirements for like a level 1, level 2, level 3, and having them work with our site operators to gain that experience. This not only is great for the site operators career track, but also for our mentors as well, who, if we have a team going out to support a mobile facility campaign, the mentors automatically know that there's a radar tech level 2 or level 3 that's already there, and then you can plan accordingly. Or on the flip side, an aerosol tech level 1, 2, 3. It just will help with our planning and resources later on as well. Now, of course, we're going to continue to work with vendors and universities and other national lab groups to support the radars, and we really want to grow on that. Some of the specific goals for partnering with the universities include creating opportunities and internships for students to get hands-on experience with the hardware and/or data. And this does line up with the User Executive Committee undergraduate engagement subgroup that also noted that they really recommend better coordination across the ARM laboratories to welcome and cross-educate interns. So, it would be great if we could have projects across labs with our interns where, Andrei maybe has an intern working on the hardware and one of the translators has an intern working on the data, that they can work together on a project. But really the goal here would be to create pipelines from the universities to ARM so that we can develop students while they're at the universities in the hopes that they join ARM as staff in the future. We want to communicate the usability of ARM observatories to researchers who may want to deploy their own systems. We are a user facility. There's a lot of instrumentation there. So even if researchers want to bring their own systems, I think that's something we need to try and encourage. A few years ago, we had a group come up, bring their radar systems up, and we just pointed the X-Zappers in vertical mode the whole time at SGP while they were up there. So we really want to open this up to more users, more researchers outside of what's now the ARM community, and bring more in. And of course, based off the roadmap to operations, we're going to be identifying what tasks can be contracted out to external partners, and we're going to look at that more and more as we go here. again, see if we can shift some of that effort and the burden from mainly on the mentor team kind of outward. Now, with community feedback and interaction, this right here is really step one. Starting to engage more with the community as we go into the listening sessions for the specific sites. Hopefully we'll get a lot more feedback on this. We really are looking to you to help us define these scientific objectives and priorities with these systems. But we also are going to be engaging with our constituency groups like Clouds and Precipitation Measurement and Science Group, the CPMSG, the ASR working groups. But also we're going to be looking more towards external organizations as well, like E3SM and NASA, to bring in more users, bring in more thoughts on and ideas on this as well. Now, we're looking at providing a mechanism to communicate radar information to the user community on a more regular basis. So we're discussing whether it's a new ARM webpage or revamp of radar.arm.gov or a combination of both. But really, we want to make sure that our users have the most up-to-date information as possible. And hopefully we can find a way to automate this so it's not as much as a burden on the mentor team to update this information for the group. One of the things, if you're a member of the old Trello boards that we used to use, we are discussing discontinuing those for now and starting discussions up on ARM's discourse page. The LASSO team was somewhat the first ones to start this up, and I think it would be a great resource to open discussions up to the broader ARM community as well. So if you want to check it out, discourse.adc.arm.gov. That's really another place we'll hopefully have discussions going in the near future. But also we want to look at other opportunities as well, like hosting radar specific breakouts at the PI meeting or something like that. So with that, I'll leave it at that. If there are any questions or comments, the one last thing I will note, please, I definitely look forward to you actively engaging in the upcoming listening sessions. It's really going to drive what we do with these radars in ARM and help us plan and prepare, with this strategy to implement them, to get them running in the best fashion possible for the scientific community. So with that, I will open it up. If there are any questions or comments, please raise your hand or put it in the chat. Or if anyone else had something to add that I didn't touch on. All right, Matt.
Hey, Adam and everyone. Sorry, I only joined about 20 minutes ago, so I probably missed a lot of what was said. Lots of meetings today, but in any case, as you're talking about the modes of operation, something came up for me that I've been thinking about for a long time with regard to some of the radar systems. And, one of the really fantastic things about the ARM Climate Research Facility is the long-term records. And, some of these vertically pointing radars are, really these data sets are the only ones of their kind, right? I mean, they're so unique and so powerful. And one of the things that I think is a challenge when using those for things like climate purpose, right? For climate studies, we're looking at transitions, we're looking at, evolution in the system over time, we're building statistics. And so one of the really important aspects there is consistency over time. And that's, it's been an ongoing challenge for ARM, but I wonder if there is a way, through ARM or through some of the communities you mentioned, internships, other things, to do some retrospective analysis of some of those continuous data streams, to be able to evaluate their consistency and stability over time, and potentially even, make corrections. Because, I know in particular that, the Alaska systems a lot, and there were a lot of issues over time. And, you hear about little corrections, there are different calibrations, things like that. And it's always been on my mind, like, is there someone at the top that's keeping track of all this and putting it in context somehow, so that then the data that goes out to the user can capture all of that knowledge somehow. And I don't know if that's been the case, or if there's the opportunity here for some of that retrospective analysis to go back over these past, long-term data sets and evaluate the stability and other factors like that.
Yeah, so that's actually a great point. And I would look to, if Jim's on the call here, because as part of the decadal vision, I think he was, we are looking to devote more mentorship time towards the data analysis, towards working with the data. We don't necessarily keep track, I guess, unless users report it to us. If they're finding biases or offsets, we won't necessarily know about that, but we would definitely encourage anyone that finds those to report them to ARM. Both, either to the radar@arm.gov like Alyssa showed, or probably better through the Ask Us or the data questions links on the footer of ARM's homepage. Jim, do you have anything?
So yeah, there hasn't been, Matt, somebody at the top or thereabouts looking at this over time, but I know Karen has spent some effort looking at these parts of the record, and she may be able to say more, but as Adam says, this is something that we definitely want to do going forward. It's something that's been suggested to us at times in the past, the idea of doing a reanalysis of some of our data sets. You can imagine that would be an extraordinary effort, but I think it is important. I think it also gets back to something that Jennifer talked about, and I wanted to comment at the time, what does this short term mean? And I think there is a distinction here between the KSERs and these scanning systems, which are much more complex. And Adam's talking about this roadmap, and we're trying to understand how do we balance what is truly sustainable, what is the science impact, and I don't think we know what is fully sustainable for the scanning radars. I think for the KSERs, we feel it is a very high priority to run those everywhere all the time. That is a core part of what we do. For the scanning radars, we think that may be more of a niche that we can provide under certain circumstances. And might that be a year? It might be a season. How can we best meet the science needs? But to close out to your point, I think that doing this long-term analysis for this and other data sets would be extremely valuable. But it will take balancing resources to make that happen.
Yeah, if you don't mind me jumping in here, that's Matt, I'm delighted to hear you raise that issue. That's certainly something that I and Mike Jensen and a bit of Scott Grandes, we've talked about doing that, and I've done some years of analysis of the old MMCR record, and it is a shame that we haven't been able to leverage the entire record overall this time, but it does take, as everyone knows, resources and people dedicated. And it's not a project that you can do like a bit here and a bit there. You really need someone to be able to just focus on that project, because it really takes a lot of attention and attention to detail. But yet I really think that there is information we can extract from that record, and it's a real shame not to try to do that. So it's partly a matter of priorities, and if there's enough community demand, I suspect that can filter up to the top and get more attention on it. But I do have a good amount of work that we have started, and I think that's something student help or postdoc help or whoever's available could be put on that if that is the community's interest.
Mm-hmm. Great. Thanks, Karen. Matt, does that answer your question?
Well, I mean, it discusses the question.
Yeah.
I mean, as for the path forward, I mean, it is a challenge, of course. It would be a huge resource thing. But, one thing that's really compelling right now, I think, is that the ARM program is actually approaching a climatology, right? And many of these instruments or measurements have been made for about 30 years now almost, right? So that's actually extraordinary if you think about some of these measurements. And so can we actually treat those as climatologies and, statistically analyze them as such? And that requires us understanding the fundamental stability of those measurements. So I just think that it's, as we're talking about, ARM over 30-year timescales, we want to be able to synthesize the data in that way. And so to me, it seems like this is something that we could reflect on within the ARM community and figure out how to go about, creating those kind of statistically robust climatological data sets. So I
think, the hard reality is that there's this balance between making the measurements and analyzing the measurements given fixed resources. So that is exactly what, when Jennifer talks about this call for the review, what we're being challenged to do, how do we best use our resources? And I totally agree, Matt, that we need to be spending more of our effort in the data, analyzing the data to make the data optimally useful, including what you're talking about, and also applying things like measurement uncertainties, other things. So I think that, but it will require, unless we get blessed with additions, reducing effort in some other areas. So it is the challenge that we're trying to assess. And one of the things we hope to get out of this series of listening sessions is understanding what are the most critical things that we do, so that to help us set up those priorities. Yeah, I completely agree.
So I guess that's maybe a good point to look to Rolanda, because we are going to be celebrating ARM 30, right? Later this spring and summer, and we'll likely be highlighting some of our data sets. Rolanda, do you have anything to add?
Yes, we're planning like a year's worth of stories for the 30 years. So it won't just happen in one story. So we have talked with Jim and have set out a plan and identified various campaigns and different data sets that we're going to be featuring for the scientific impact. So we encourage everyone to participate.
All right. Any other questions or comments or feedback here? I know it was a lot of information. If you do have questions or follow-on comments, please feel free to email me, Theisen, I'll put it in the chat, at anl.gov. So I'm definitely open to communicating further. Otherwise, I look forward to seeing you at the subsequent listening sessions. So where we'll actively be discussing. There will be less presentation, more just get in and start discussing. So, all right. Thanks, everyone. Enjoy the rest of your day.